Hello everyone, my name is Tian Changbo. I'm from China. Now, my paper title is Topology Self-Optimization for Anti-Tracking Network via Nodes Distributed Computing. I will discuss my work from the following aspects: introduction, convex polytope topology, topology self-optimization, performance evaluation, and conclusion. Introduction. Anti-tracking network aims to protect the privacy of network users' identity and communication relationship. The research of P2P-based anti-tracking network has attracted more and more attention because of its decentralization, scalability, and widespread distribution. But the P2P-based anti-tracking network still faces the attacks on network structure, which can destroy the usability of anti-tracking network effectively. So a secure and resilient network structure is an important prerequisite to maintain the stability and security of anti-tracking network. We propose a topology self-optimization method for anti-tracking network via nodes distributed computing based on convex polytope topology we call CPT. Our proposal achieves topology self-optimization by each node optimizing its local topology in optimum structure. Through the collaboration of all nodes in network, the whole network topology will evolve into the optimum structure. The contribution of our work is shown as following. First, we apply convex polytope topology in the construction of anti-tracking network topology. Anti-tracking network based on CPT has a better robustness. Second, we define an optimal topology model based on CPT to achieve the topology optimization of anti-tracking network. Third, we propose a topology self-optimization method based on CPT, which improves the security and resilience of anti-tracking network. First, we need to introduce the basic concept of convex polytope topology. Convex polytope topology, in brief, is CPT. CPT is a structured topology in which all nodes are structured into a logical structure of convex polytope. One of the advantages of CPT is the elimination of cut vertex because any two nodes in CPT has at least two non-overlapping passes. In this case, some nodes are removed from CPT. CPT can still keep the convex polytope structure except the nodes in ring connection. If some nodes are removed from CPT, CPT still keeps the convex polytope structure. The nodes in ring connection are removed. CPT is split into two parts, but in the practical application, it is a small probability event that the removed nodes happen to be in the ring connection. So when some nodes are removed, the timely recovery of CPT will keep the robustness and invulnerability of network. If one node breaks the link with its neighboring node, it has to instruct the two relevant neighboring nodes to build new connection. As illustrated in the illustration, for example, in the anti-tracking network based on CPT, if a node V0 breaks the link with the node V4, because the two surfaces share the same link, V0, V4, the two neighboring nodes V1 and V6 need to build a new connection with each other. Likewise, node V0 breaks the link with V3, then its two relevant neighboring nodes V2 and V5 build new connection with each other. The optimum local topology provides the useful information for each node to optimize its local topology, but the optimization of each node's local topology cannot totally depend on the optimum local topology. The effect of topology adjustment on other nodes also need to be taken into consideration, so the self-optimization of topology is achieved by nodes collaboration. In the anti-tracking network based on CPT, each adjustment of topology involves 4 nodes, 2 nodes executing disconnection operation and the other 2 nodes executing connection operation. So each adjustment of topology should be confirmed by the relevant 4 nodes. To evaluate the effectiveness of our proposal, we use ring topology and centralized topology separately illustrated in Figure 5 and Figure 5b to construct a node with 1,000 nodes, and deploy the self-optimization algorithm on these networks. We use d-min, d-max, and d-avg to denote the minimum node degree, maximum node degree, and average node degree of all nodes respectively. We define one round of network self-optimization as that all nodes finish the optimization of its local topology. Then we calculate the above criteria in each round of network self-optimization to analyze the effectiveness of our proposal. In our experiments, all the networks are constructed in centralized topology. The network is constructed in centralized topology in which one node has connections with all other nodes, so the central node has a very high degree. At first, each node needs to maintain its local topology in maximum connectivity. Dmax keeps unchanged for a few rounds. After the network reaches the maximum connectivity, Dmax decreases sharply and keeps nearly 9 at last. The change of Dmax shows the effectiveness of network self-optimization. The two pictures shows in the first picture, it illustrates the change of node degree in the self-optimization process of network based on ring topology. The second picture shows the change of node degree in the self-optimization process of network based on centralized topology. In the two kinds of network topologies, our proposal, the topology self-optimization methods can make the node degree to a balance level. In order to present the effectiveness of network self-optimization intuitively, we calculate the node degree distribution after network self-optimization in ring topology and centralized topology respectively. Dr denotes the node degree distributed generated in the ring topology. DC denotes the node degree distribution generated in centralized topology. From the experimental results in the picture, we can see that no matter in which topology, in the work, our proposal can achieve the self-optimization of anti-tracking network to make the topology evolves into the optimum structure. The optimum structure is that the node degree of all nodes, the node degrees of all nodes in the network evolves into balance. We separately simulate 3 networks with 2 surrounded nodes according to CPTs NN and T hash. Through removing p% of nodes from the 3 networks each time, we use the node number of maximum connected graph to measure the network resilience when confronted to dynamic network scenario. The optimal structure of CPT has the maximum network connectivity conforming to the convex polytope structure and the uniform distribution of node degree. So it is not too much difference between top P removal and random P removal in the network when with balanced distribution of node degree. Consider the ideal situation if the node degree of all nodes in the network with Ts is close to 6. The removal of any nodes has the same effect on the topology structure. So, from the experimental result in the pictures, we can see that the network based on CPT has a very strong robustness. With the increase of the percentage of removal nodes, CPT still has a very high percent of maximum network connectivity. The experiment shows the effectiveness of our work. Conclusion: we propose a topology self-optimization method for anti-tracking network via nodes distributed computing. Our proposal applies convex polytope topology in the construction of anti-tracking network. Based on CPT, we achieve the topology self-optimization for anti-tracking network. We also define an optimum structure of CPT in which network has maximum network connectivity and balanced distribution of node degree. Each node optimizes its local topology, then the whole network evolves into optimum structure of CPT through the collaboration of all nodes. Each node first calculates its optimum local topology according to its local topology situation. Then, each node negotiates with its neighboring nodes to adjust its local topology according to the calculated optimum local topology. When the relevant nodes arrive at consensus, the local topology will be adjusted according to the optimum local topology. or we will keep the local topology unchanged to make sure each adjustment of local topology is beneficial to all the relevant nodes. This concludes my statement. Thank you, everyone. If you have any questions, please email to me. The email is shown on the screen. Thank you.